Assalamualaikum and hello everyone. My name is Khaliq and my partner is Hariznaim. Today, we are going to present Euler's method. So, our first question is, what is Euler method? Euler method is used for approximating solution to certain differential equation and works by approximating a solution curve in a line segment. In other words, Euler's method is a first-order numerical procedure for solving ordinary differential equation with a given initial value. In Euler methods, you can approximate the curve of the solution by the tangent in each interval, that is, by a sequence of short line segments at steps of h. In general, if you use more step size, the accuracy of approximation increase. This is the general formula for Euler method. Yi plus 1 is equal to Yi plus Hf xi yi, where Yi is plus 1 is the net estimate solution value, Yi is the current value, H is the interval between steps, fxi yi is the value of the derivative at the current xi yi point. Now, let's take a look at an example of the Euler method. For the first numerical example, we will choose a problem to which we know the answer. The initial value problem described by y prime equal to 1 minus 2xy, y0 equal to 0 has a solution yx equal to e to power of negative x square integrate x0 exponential to power of negative t to power of 2 dt, which is known as Lausanne integral. Here we solve equation 1 numerically and see how the value compare with the analytic solution. Using Euler method, the value of yx are tabulated for x equal 0, 0.5, with h is 0.1. Recall the Euler formula, yn plus 1 equal to yn plus hfxy, and fxy in this problem is 1 minus 2xy. Therefore, we got y1 equal to y0 plus 0.1 fx0 y0. The answer is 0.1. For the y2, y1 plus hfx1 y1. The answer is 0.198, and so on until x equal to 0.5, because we have a 5 step. Comparing this numerical result with the analytic one got by substituting in equation 2 give the table. This is a table which consists of xn, yn numerical result, and yxn for analytic result.
Hello, my name is Ahmad Hariznaim bin Muhammad Zaidi, metric number 146378. So, from my part, I will present the past year question that related to Euler method. Okay, so first, the question is from 2018, question 1. For this question, we need to solve the initial value problem by using Euler method with h equals to 0.5 to estimate the value of y 1.0. From the question, we have dy over dx equals to ty plus y squared minus 2 with initial value of y0 equals to 1 and h equal to 0.5, and we need to find the value of y 1.0. Since h equals to 0.5, we only need 2 steps to solve this problem. Okay, so for the first step, we find the y1 equals to y0 plus hf t0 y0. Then we insert the value that we have for t0 and y0, and we get the answer for y1 equals to 0.5. Okay, for the next step, y2 equals to y1 plus hf t1 y1. Then we insert the value that we have for t1 and y1, and we get the answer for y2 is equal to negative 0.25. Hence, we can conclude that the value for y1.0 is equal to negative 0.25. Next, we will go for the real-life problem that can be solved using Euler method. This question is also from past equation 2018. For the first question, we need to prove that the Euler method applied to initial problem can lead to Pn equal to bracket 1 plus 2.5 times 10 to the power of negative 3 h bracket to the power of n times 58.043, where a Pn is approximation to P and h. So first, we know that generally Euler method can be expressed in yn plus 1 equals to yn plus hfn. Then, from the question, we have the equation dp over dt equals to 2.5 times 10 to the power of negative 3p, and p initially is 58.043. Then, we can apply the general Euler method to this equation, which we get Pn plus 1 equals to Pn plus hfn, where Fn equals to Fhpn equals to 2.5 times 10 to the power of negative 3 Pn. Okay, suppose we let the n equals to 0, we will get P1 equals to P0 plus h open bracket 2.5 times 10 to the power of negative 3 P0 close bracket. Then we simplify the equation. We will get P1 equals to open bracket 1 plus 2.5 times to the 10 to the power of negative 3 h close bracket times P0. Then if we further the order to n equals to 1 and n equals to 2, we will get for the n equals to 1, we will get P2 equals to P1 plus h open bracket 2.5 times 10 to the power of negative 3 P1 close bracket. Then we can see here we will get 1 plus 2.5 times 10 to the power of negative 3h P1. So if we look at the previous order, which is P1 equals to 1 plus 2.5 times 10 to the power of negative 3h P0, then if we insert the value, we will get the 1 plus 2.5 times 10 to the power of negative 3h close bracket to the power of 2 times P0. Okay, for n equals to 2, we have P3 equals to P2 plus h bracket 2.5 times 10 to the power of negative 3 P2 bracket. Then we simplify and we get bracket 1 plus 2.5 times 10 to the power of negative 3 h bracket P2. Since we know that the value of P2 equals to bracket 1 plus 2.5 times 10 to the power of negative 3 h bracket to the power of 2 times P0, we can insert the value into this equation. Then after we simplify, we get P3 equals to bracket 1 plus 2.5 times 10 to the power of negative 3h bracket to the power of 3 times P0. From this, inductively, we can see that the pattern leads to Pn equals to bracket 1 plus 2.5 times 10 to the power of negative 3h bracket to the power of n times P0. Therefore, we prove that the Euler's method applied to initial problem can lead to Pn equals to bracket 1 plus 2.5 times 10 to the power of negative 3h bracket to the power of n times 58.043. For next question, we need to use a time step of h equal to 6 months to approximate the predicted population for the year of 2050. We can use the equation we get from previous question. First, since h equals to 6 months, suppose we calculate 1996 to 2050 in years, we will have 54 years. 6 months is equivalent to 0.5 year. So, we need 108 times to get 54 years. So here, we have n equals to 108 and h equals to 0.5. We insert the value in the equation we get the answer, which at 2050, approximately the population in Malaysia is 66.427 millions. For conclusion, Euler method is one of a method for approximating solutions that do not change rapidly. We generally try to find bounds on the error that will tell us how well an approximation should do. Next, this method will provide error-free predictions if the solution of differential equation is linear, because for a straight line, the second derivative would be zero. Also, we know that Euler method is a first-order method to solve ordinary differential equations with a given initial value. Finally, there are some applications of Euler method, which is in physics, we can use in projectile motion, which we can predict the trajectory of an object in a projectile motion with significant air resistance. Second, as we have shown in the past equation, we can use to calculate the population growth at a certain area with known initial population. Lastly, we can use in economic models that use first-order differential equations, for example, Cobb-Webb model and also basic Keynesian model. So, I think that's all from our group. Thank you and have a beautiful day.